All right, so starting with module 16 review. Hey, number one is really just asking what is the definition of similar triangles. So what is true if we know that triangle ABC is similar to DEF? Now for this, we don't need a triangle. The triangle that is there is not even the one it's referring to. What are the two things that we know that are true if we have similar triangles? First, we have angles that are congruent. So I can state that angle A is congruent to angle D. Angle B is congruent to angle angle E. And angle C is congruent to angle F. So we know that corresponding angles are congruent in similar triangles. We also know that our sides are proportional. So this is where we've set these up. So AB is to DE as BC is to EF as AC is to DF. Now, how am I coming about knowing which ones match up? It's from our similarity statement. Okay, so this statement right here. If you look at it, and this is why I think it's easier to look at the similarity statement than a triangle, because a triangle, you have to reorient. Hey, here I can just look. A is my first one. Well, what's my first letter over here? D. My second one is B, so it matches up with that. That is E. So as you look at all these, I go AB. Well, those are my first two. Well, what would that correspond to? That correspond to DE. So the similarity statement tells you the order of the letters and how they match up with each other. So it's the easiest to write what angles correspond and then therefore are congruent, and what sides match up so you can write your proportional statements. Okay, so as we look at number two, now we're referring to this picture over here on the right. So are the two triangles similar? So as we look at this, one of the big things we need to get in the habit of is seeing this shared angle. So we can say that angle C is congruent to angle C. And then what do these arrows here mean? It means that they are parallel. So when we have parallel lines, you remember back to module 14-15, I can then state a couple things. I can state that that angle is congruent to that angle, or vice versa, we can say this angle is congruent to that angle. And the reasoning for that is corresponding angles. We have our parallel lines with our transversal. Now, we only need two of those. So I'm going to use the first one I wrote. So angle CDB is now congruent to angle CEA. If you wrote angle E is congruent to angle D, I would accept that, but the more correct way of writing it is this here. And then are the two triangles similar?
Yeah.
Our answer is yes. And what's our reasoning why? Our reasoning would be angle, angle. And there's our support for angle, angle. And then it says write a similarity statement. Now your similarity statements, pick one triangle, and it doesn't matter what order you go on the first triangle. So I'm going to go with the biggest triangle, and I'm going to go A, C, E, and that is now similar to triangle. And this is where it does matter. I have to go the same order. So if I started with A, for the smaller triangle, what letter would we start with?
B.
We would start with B, because those were the two that were congruent. Then we go to our shared angle of C, and then back down the other side for D. So the first triangle doesn't matter. You can choose whatever order you want to do it in. But then once I choose that order, I have to match that order. If you had wrote CDB for that second one, that would not be correct. You'd lose a point. So make sure you go in the same order. So question is, QRS similar to PSQ? If so, state why and write the similarity theorem. So based on what they give us in the triangle, of the three, angle, angle, side, or side, side, which one does it look like we're initially going to have to use? Okay, why side, side? It gives us all three sides, and we do kind of have an angle that we could potentially use, but let's do side on this. So if we're doing side, we then need to determine which ones match up. Fortunately, they give us the similarity statement here, so we know which sides match with which. So I'm going to go QR. So that's going to be 15. And that matches with PS. So that's 12. And then that has to be equal to, I'll go RS, which is 25. And that matches with SQ, which is 20. And then our last one is QS. Okay, so that's now on the same shared side, but now that it's a different part of that triangle for the triangle on top. So that is 20, and that matches up with PQ, which is 16. Now, as we talked about, there's a bunch of different ways you can check. I think the easiest is at this point is just take a calculator and get the decimal of each of them. So 15 divided by 12, 25 divided by 20, and 20 divided by 16. Okay, so we get 1.25 for 15 divided by 12. Okay, so we get 1.25 and 1.25. So if those are all the same, what does that tell us about the triangles? Yeah, we would say that they are similar. So we'd say yes by side. And that's our similarity theorem on that one. Now, let's say just one of these. Let's say instead of that second 1.25, let's say we had 1.3. Would those triangles be similar? No, all three values have to be equal in order for the whole triangle. So if you get one that is off, that's why you need to check all three. You can start by checking two if you want, and as soon as you get one off, you're done. But if you get two that are correct, you need to check the third one as well if you're doing side. So this one would be yes by side because that one was 1.25. And so we're good there. All right, number 4. Hey, are they similar? So as we look at it, again, similar to the one we did on number 2, I have a shared angle, so I have angle B. It's congruent to angle B. And then we have parallel lines, so then I can state that angle BDE is congruent to angle BAC. So that tells us angle, similarity. They asked for a similarity statement. That should say theorem, because we already have the similarity statement right there that we could use. All right, so that one again is yes by angle. All right, number 5. In the figure to the right, triangle RST is similar to triangle XYZ. So they're stating that they are already similar. So since we know they are already similar, that means we have congruent angles, and relevant to what we have here, we have proportions of sides that have to be equal. Now, you have the triangles over here, but again, like I talked about earlier, the similarity statement is going to be more helpful. So as we look at A, the way I look at it is I go back to my similarity statement. So I have RS. So I have RS. Does that match up with XY? Yeah, RS were the first two letters. XY are the first two letters. So this statement so far is good. Then we go ST to YZ. So it's the second and third letter and second and third letter. So that one works. Okay, let's check B. So B, we now have RS again, but now we have XZ. Are those the same order of letters? No, RS is the first two, XZ is first and third. So we know B doesn't work. Okay, check C. So we have RT, first and third, is to XZ, so that works. Then we have RS, which is first and second, to YZ, which is second and third. So that one now does not work. And last, we have D. So we have RT, which is first and third, is to XY. Well, that's first and second, so that one doesn't work. So then A ends up being our only correct answer. So you can see why having the similarity statement's a lot easier to check it than trying to base it off of the triangles over there. All right, number 6. Name one piece of additional information necessary to prove the two triangles to the right are similar. Now you have two choices. This is one that came from a previous quiz. I think the easiest would be if I was told that angle R is congruent to angle C. And then with that, I would have RF and is to CT, and LR is to DC. And with that, we've now shown two sides and an angle. So then our similarity reason, our theorem is side, angle, side for that one. So the extra piece of information you want would be the angle, because you have the sides that are already proportional. So that is one way you could do it. The other way you could do it is ask for the third side, so that you could write, we already have RF is to CT, as LR is to DC, so then we just incorporate our third side here. So then we'd go LF is to DT. If all three of those are proportional, as we saw in number 5 or 4, then we would have side, side, side. And then our similarity statement, if we're asked to write it, again, pick whatever one you want to start with. I'm going to start with the smaller triangle, and I'm going to go L, R, F. So I go along the longest known side and down the shortest known side, and that's going to be similar to triangle DCT. One. Looking at module 17 now. And number 1, if we know in a triangle that we have two sides that are parallel, we then know we have some ratios that we can set up. Now there's a couple that would fit within some of these. I just want you to practice of writing these. So as I look at it, AE is to AD. So then what we'd compare that to is the opposite side. So that would be AB is to AC. And then as we look at the second one, we have AE is to AB. So now we're going across. And you could do a couple of those. You could do AD is to AC. You could also do ED is to BC. So I'll do that one. So ED is to BC. So you can see you have some options as long as you're comparing same with same. Okay, so I did top, top, bottom to bottom. All right, then we have ED is to AD. So then that would give us BC is to AC. So again, we did bottom to the whole thing, bottom to the whole. And last, we have AE is to ED. So then we would go AB is to BC. All right, number 2 for A and B, if we know that we have parallel lines in a triangle, we have the triangle proportionality theorem, which states, and let's call this X, that as we compare our values, those are going to be the same. So I'm going to go 4 is to 8 as X is to 9. We cross multiply, and I get 4 times 9 is 36 equals 8x. Divide by 8, and x equals, we get 4.5. We talked about all these different ones. So as I look at this again, and if I wrote, say, side to side, 4 is to x as 8 is to 9. So we compared them slightly differently. But when we cross multiply, we still get 4 times 9, and we still get 8 times x. That's, as long as you do same to same, it doesn't matter which way you do it. I can go left side to right side. I can go top to bottom, as long as you stay consistent. Hey, on B, same type of question. Let's go 12 is to x as 16 is to 4. Cross multiply, and you get 48 equals 16x. Divide by 16, and x equals 3. Okay, so again, this is more about understanding what proportions you can set up, because once you've done that, we cross multiply, which you've been doing for a while, and then we're dividing. So it's really 2 steps of computation, which majority of it you can just do with your calculator. All right, so similar triangles. Sarah is 5 feet tall. We want to find the height of the flagpole, so this is similar to the type of problems we did when we went outside. So I'm going to draw Sarah. Again, it doesn't have to be anything fancy. I'm just drawing a stick. And Sarah has a shadow of 15 feet. And then we have our flagpole, which we don't know what the height is, but we know the shadow is 45. Same deal, similar triangles, we're going to set up proportions. So in this case, I go height to height, so 5 is to h as 15 is to 45. Cross multiply, so I get 15h equals 225. All right, then divide by 15, and h equals 15. Okay, good. All right, number 1, module 18 here. So find the value of xy. So I'm going to call my xy here, call it x. Now as we look at it, 65 is our known angle. So in relationship to 65, what is our x? Is it opposite, adjacent, or hypotenuse?
Adjacent.
It is our adjacent. And what is the 19? That's our hypotenuse. What trig function uses adjacent and hypotenuse? Forgot, one of the first things I always tell you should do when we do these types of problems is make sure you write down SOHCAHTOA. Okay, so I'm looking for AH. Well, there's my AH with C, so I have cosine. So I have cosine, and then after your sine, cosine, or tangent always comes your angle. In this case, your angle is 65. And that equals adjacent, which is x, over the hypotenuse, which is 19. We're now solving for a side length, which means whenever we're solving for a side length, we do what? Yeah, we multiply by the denominator. In this case, it is 19. Sometimes it may be our variable. So then we get 19 cosine of 65 equals x. Punch that into our calculator, and x equals 8.02. It says round to the nearest tenth, so that 2 rounds down, so we just get 8 or 8.0 if we want to be specific there. All right. Now we want to find yz. I'm going to call that y, just use a different variable there. I would use the most accurate number we have, so I would use 19. We're still using our angle of 65. So then the y is what part of that triangle? It is our opposite. And we're still using our hypotenuse. So what trig function uses opposite and hypotenuse? Sine. So SOH, opposite hypotenuse, is our sine. So then we get sine of 65 equals our opposite, which is y, over our hypotenuse, which is 19. Again, we're solving for a side, so we're going to multiply by our denominator. Again, this time it is 19. And we get 19 sine of 65 equals y. Type that into your calculator. So we get y equals 17.21, so that just rounds to 17.2. All right, number 3 and 4, we're talking about our angles now. So first one, we want D. And they give us two sides. They give us 24 and 15. So that 24 is what? Is that the opposite, adjacent, or hypotenuse in relationship to D? It is our hypotenuse. How do we tell it's our hypotenuse? Yeah, it's across from your right angle. It's the one side that is not touching your right angle. Then with that, our 15 then becomes our what? It is our adjacent, because it's touching our angle. So as we already talked about, we had adjacent hypotenuse is cosine. So we would write cosine, and it's cosine of our angle. In this case, we don't know our angle, so it's cosine of D equals adjacent, which is 15, over hypotenuse, which is 24. Now we're solving for an angle, which means we need to do the inverse. So we get D equals cosine inverse of 15 over 24. Type that into your calculator. Again, if we want the inverse, what do we need to type in first? Second. Yeah, hit second and then cosine. So we get D equals 51.31. It says to the nearest degree. So then our nearest degree would be just 51, because 0.3 would be a 10th place. We just want the degree, so it's just 51. Now, if we want to do F, there's a couple ways you can do or solve for F. We can set up another trig function. But if I know that D is 51 and E is a right angle, which is 90 degrees, how do we find a third angle in a triangle? Yeah, add those two together and subtract from 180. So we would have 90 plus 51 is 140. So you have 141, and then we go 180 minus that 141, which gives us 39 degrees on that one. All right, number 5. So here all we're doing is writing it as fractions. So we're looking at sine of S. So from S, let's label all our sides. So 13 would be our hypotenuse, 12 is our opposite, and 5 is our adjacent. So sine is O and H. So this would be 12 over 13. Cosine is adjacent over hypotenuse, so 5 over 12. And tangent, sorry, thank you, 13. And then tangent is opposite over adjacent, so we get 12 over 5. Now we go to sine of A. Now once we go to A, that changes a couple of our sides. Our adjacent now becomes our opposite. Our opposite now becomes our adjacent, and our hypotenuse stays the same. Your hypotenuse does not change. Only your opposite and adjacent change in relation to what angle you're dealing with. So sine is now opposite, which is 5, over hypotenuse, which is 13. Cosine is adjacent, which is 12 now, over hypotenuse, which is 13. And tangent is now 5 over 12. Now we jump into some word problems. So number 6, boy flying a kite is using all of the 50 meters of the string. The angle of elevation is 12 degrees. How high is the kite flying above the ground if the boy is 1.7 meters tall? So here's our initial triangle that we want to work with. And we want to find that initial height of that triangle there. So I'm actually going to call it X. Because what we really want to find is this total height, where we know that this portion is 1.7. 1.7 there, but we need to find that X. So I'm going to pull that triangle out. And I have 12 here, I have 50 here, and I want to find that. Now as we look at this, I have my angle. This is now my opposite, and this is my hypotenuse. So we're going to use sine of 12 equals X over 50. Multiply by 50 on both sides. And you get 50 sine of 12 equals X. Type that in your calculator and you get X equals 10.4. But that is just this height here. So we need to go 10.4 plus the height of the boy, which is 1.7, which gets us to 12.1 meters. Hey, number 7, we have to draw a diagram now. So in this problem, we have a building and us standing somewhere away from that building. Our building is 850 feet. Our distance away is 400. And we want the angle of elevation, so that's that portion right there. So in relation to that angle, our 850 is our opposite. Our 400 is our adjacent. So opposite and adjacent now becomes tangent of theta equals opposite, which is 850, over adjacent, which is 400. Solving for an angle now, so we need to do the inverse. So theta equals tangent inverse of 850 over 400. So theta equals...
You guys want to round it?
Okay, so we get 64.79, which will round to 64.8 degrees. All right, now let me do a problem because we haven't solved for one like this. So let's say we had tangent of 15 equals, let's go 6 over x. Same deal, we're solving for a side length on this one. So we multiply both sides by our denominator, which in this case is x. So then we get x tangent of 15 equals 6. The previous ones we multiplied our denominator, but it was a number, so then we're done. In this case is our variable x by itself. X is not by itself. What is with it? Tangent of 15. What do we do with that tangent of 15? Yeah, we divide it up. And then once we do that, we get x equals 6 tangent of 15. You type that into your calculator and you get an answer that way. Okay, so just another one. Just one more step. We just got to realize x is not by itself, so I need to divide my whole trig function, the sine, cosine, or tangent, and the angle over. And what's the answer? 22.3?
22.39.
39, so 22.4. Okay, so just one that we hadn't done yet. I want to make sure we understood that. All right, little review that you're going to have dealing with parallel lines. So corresponding angles are angles in the same location. So I'm going to state 1 and 5. Same side interior angles now become 3 and 5. They're on the same side and they're in between, so that's the interior. Then same side exterior, again, is going to be on the same side, but now we're going to be on the outside, so 1 and 7.
It can be 1 and 3.
Alternate interior means we're going to be on opposite sides, but we're going to be in between. So you can go 3 and 6, or you can go 4 and 5. There's a couple different answers for each of these. And then alternate exterior angles is 2 and 7 or 1 and 8.
And then 3 and 4.
Okay, again, they're on opposite sides, but exteriors, so they're on the outside now. And then our linear pair,
3 and 4.
there's a bunch of these. I'm going to go sticking with my top portions, 1 and 2. Could have done 1 and 3, 2 and 4, 3 and 4, 5 and 6, 5 and 7, 6 and 8, 7 and 8. There's a bunch of them that you could do. Okay, linear pair, remember, they have to be right next to each other. So 1 and 2, I almost have to be able to draw that continuous arc between them. All right, looking at number 2. So we're talking about angles 3 and 5. So what type of angles are 3 and 5? 3 and 5 are same side interior, which if two lines are parallel, same side interior angles have to be what?
Can't add up to 180.
They have to add up to 180, which means they are supplementary. So here they tell us that measure of angle 3 plus measure of angle 5 is 180. So is line L parallel to line M? Well, based on those adding up to 180 and that they are same side interior angles, we would say yes, because same side interior angles are supplementary. And last one. If we know measure of angle 1 is 80, measure of angle 2 is 100 because they are linear pair, and linear pairs are supplementary.
Angle 3 is 100.
And then angle 3 becomes 100.
Angle 4 is 80.
And you can do vertical angle to 2, or you can do linear pair with 1. Angle 4 is 80. Again, a bunch of different ways. You can do vertical angles with 1, linear pair with 2 or 3, and then you work from there. 5 is corresponding to 1. Or alternate interior 4. 6 is 100. 7 is 100. And 8 is 80. 7 is vertical to 6, or it's corresponding to 3, or it's linear pair with 5. You have multiple options for those all to work out.